My name is Jeff Reimer. I'm the Abraham E. Duckler Endowed Professor of Chemical and Biomolecular Engineering at the University of Houston. My research focuses on crystal engineering, which itself is a broad area, but we focus on two key applications. One, the design of catalysts, where we try to improve the properties of these for processes such as production of gasoline or chemicals, and with the changing energy and environmental landscape, many of these materials play a key role in that transition. On the other side, we focus on crystallization of human diseases, where the goal is to reverse engineer them. In other words, develop molecules that can help inhibit their formation in diseases such as kidney stones, malaria, and more recently, atherosclerosis. So the Welch Center is focused on nucleation, where we've seen in the last 10 to 15 years the emergence of many examples of what we call non-classical nucleation. This is a very new area of research where we want to focus on studying these systems. Particularly, one of the challenges associated with this is to control crystal structure. And where we see this playing out predominantly is in the area of pharmaceuticals, where many pharmaceutical drugs can have as many as 3 or more different types of crystal structures. And so we would like to take the Welch Center and establish a pharmaceutical consortium for molecular systems where we can then manipulate these to control processes such as nucleation of different crystal structures. So the Welch Center is going to be a part of a broader effort at the university to expand core facilities, specifically in the area of materials research. And so there will be existing facilities here that will be adapted to accommodate lab space, for example, for our center as we expand this in the coming years. Receiving this Catalyst Center grant from the Welch Foundation in its inaugural year was a game changer for us. The team of researchers that we put together, we had been looking for years for different funding avenues to support this type of research, and the Welch Foundation provided that for us. This center attacks a very central problem in the field of crystallization. How do we control nucleation? And this applies across a broad spectrum of different materials. Although we want to focus specifically on pharmaceuticals, what we learn in this project within the center of people that have a synergistic combination of both experimental and computational expertise is to then apply this in the future in a broader sense to other types of materials that expand beyond pharmaceuticals. The team of collaborators that we put together for the Welch Center come predominantly from chemical engineering and chemistry. It's a group of people that had in the past worked together in teams of 2 or 3, but the Welch Center gave us a unique opportunity to bring everyone together synergistically, both experimental and computational, with their expertise that are going to allow us to basically do things that we could not do in normal grants, for example, from the National Science Foundation or the Department of Energy. It's an exciting time at the university for materials research, and the Welch Center that we got is just the beginning of what we envision to be larger efforts to expand with more center grants, for example, from the National Science Foundation, where we can build upon the platform that we've developed with these types of Welch Centers to go into areas beyond pharmaceuticals, for example, in energy and the environment.